In this short lecture, I want to remind you of one of the basic things that you learned in your intro programming class, which is the syntactic distinction between a location that one assigns into and a value that's stored in that location. In languages like C, Scala, and Scheme, I can define mutable variables and I can update those variables. And the question that we're interrogating here is the meaning of the symbol X in expressions like this. Let's just zoom in on the C syntax. In this expression, what does X mean? And of course, the answer here is that there's two different meanings of X. If we look on the right-hand side, then X denotes the value stored at some location in memory. So we take that value, we add 1 to it. But then if we look on the left-hand side, this is not actually denoting the value of memory. No, this is saying I need to update the storage location denoted by X. So here it's actually referring to a storable location. This distinction between left-hand and right-hand side has been studied for a long time. Unfortunately, this syntax using the equal symbol we inherit from Fortran. Other languages such as Pascal have attempted to use other notations for this, like a colon equal or other asymmetric symbols, but those, for whatever reason, aren't popular. So we're stuck at the moment with this kind of symbology. And so when we talk about the two sides of this assignment operation, we use the terms L mode for the left-hand side and R mode for the right-hand side. When we think about expressions in our language, we typically think about the right-hand side, that is the expressions which yield values. But in fact, there's always an expression language also on the left-hand side. And those expressions need to yield addresses. These are what we call L values. And what this means is that effectively we have an address at which we can store whatever result we have to store. Let's take a look at some examples of L values in C. Here I have 5 variables declared. And if I think about their image in memory, they'd look something like this. X holds the value 5, Y holds the value 6, P holds the address of X, Q the address of Y, and R the address of P. What am I going to do on these 3 lines down here? Well, the first thing is to update R to hold the address of Q rather than P. Then I'm going to copy P into Q. So we're copying the value of P, which is the address of X, into Q. And so we'll update that here. And then we're going to double indirect through R. So what does this mean, star star R? Well, if I just said R gets something, it's clear enough. I'm referring to this location. If I'm referring to star R, well, what location is that? Star R is whatever the address is held in R, and it's going to refer up here because currently it's the address of Q. What's star star R? Well, it just does that indirection one more time. So now we take whatever is in Q and we go up there. So this is the address of X. And what this is going to do then is update X to be 7. This is a non-trivial use of L values. Note that we have in C this ability to create mutable pointers. We can update them arbitrarily. We can follow long chains of pointers. This is essentially just going 2 links down instead of 1. Normally we're used to expressions where we update like star P gets something. Instead, star star P just follows 2 links. So here, R, Q, and star star R are all valid L values. These are all expressions that can show up on the left-hand side of an assignment. In C, temporary values are not assignable. Now this requires some knowledge of what it means to be a temporary value in C, and it's not always immediately obvious, but I'll pick an example here which is quite obvious. In the worksheets this week, you'll see some more tricky examples. Here, if I take x plus y, this is a temporary value which is not assignable. If you try to run this program in a C compiler, you'll get an error message. Note that Clang tells me that you cannot take the address of an R value of type int. So it's saying, I'm sorry, this is an R value. And GCC instead says, well, you're not giving me an L value. So here it says, I'm sorry, I need an L value for taking the address of operator. In exactly the same way, the languages will give me an error if I try to immediately assign into the result of an expression. And so what you see here is the statement, the expression is not assignable from Clang, and GCC saying, well, I'm sorry, I need an L value again in order to do assignment. Now you might think that this means that we can never have an expression as an L value, and as we just saw, that's not true. We can have complex expressions which give us L values. And one of the keys to understanding any programming language is to understand what the L values or the assignable locations are. In C, the best way to do this is to ask the compiler. It will tell you. So if you have a question about whether or not something is an L value or not, you can concoct a little program like I just did and see what the compiler says. Eventually, you'll have some intuitions about what's considered a temporary expression in C and what is not. And in particular, as an obvious example, the result of an addition is considered a temporary expression, and it's not actually assignable. But as we've seen, L values may actually involve computation as an R value. In other words, in order to determine the assignable location, I might need to evaluate some value expressions. An obvious example is an array where I have the value expression n plus 2. I need to figure out what n plus 2 is in order to know which location to assign in memory. Perhaps less obvious is that ARR itself might be a complex expression. And that's true also for fields. I may have an object which is a complicated expression giving me something. And in fact, these things can nest. I can, for example, have an object variable upon which I invoke a method and then get out a field. If that field's an array, I can index the array. If that gives me an object, I can then invoke a method on that object. If that then gives me another object, I can look at a field of that one and then assign the thing. So these left-hand side expressions can get arbitrarily complex. I mentioned the concept of LVAL because we need to talk about parameter passing. And when we're passing parameters, it's significant whether or not the expression we're passing is an LVAL or not. In C and C++, the shades of LVAL can get quite complicated. C++ has the notion of L value, which is defined in the standard. It also has the notion of a PR value, a X value, a GL value, and an R value. Why does it have all of these complex categories? These have to do with different shades of sharing and copying that are expressible in the language, and it can get quite complex. I always say if you think you know C++, you don't know what you're talking about. The language is so complicated. But let's go back and look at some more familiar languages and see how L values are used in parameter passing.